Why large language models should not test software. Silicon Valley loves a hammer in search of nails. Every new technology that promises transformation is quickly thrust into corners of the economy where it plainly does not belong. The nuclear age was accompanied by visions of atomic cars and atomic home appliances. The early internet produced pet food delivery firms that shipped at ruinous cost. Spreadsheet software, first embraced as a way to track budgets, was misapplied to everything from real estate speculation to amateur epidemiology. Today, large language models, LLMs, are being pressed into a role for which they are wholly unsuited: the testing of software systems. The pitch has surface appeal. If these models can write code, surely they can test it. If they can pass law exams, surely they can verify the integrity of a banking application. Yet this leap of logic misses a fundamental truth. Software testing requires reliability, reproducibility, and determinism, qualities LLMs by nature cannot supply. To use a vivid analogy, deploying LLMs for software testing is like leaving infants in the care of a bulldog. The dog may mean well, but its instincts are unpredictable, and the stakes are unforgiving. Pattern machines, not truth machines. LLMs are remarkable creations, but they are built for a narrow purpose: predicting the next token in a sequence of text. Their intelligence is a statistical one, a gift for spotting patterns across vast oceans of data. They can recombine those patterns to generate novel sentences, poems, snippets of code, or even plausible-sounding medical advice. This probabilistic machinery makes them powerful assistants for brainstorming, drafting, and prototyping. Ask for 3 marketing slogans, and they will supply 30. Need a sketch of how a new feature might look in code? They will oblige in seconds. In the creative front end of business, where ambiguity and iteration are virtues, such tools are invaluable. But when precision is demanded, their weaknesses glare. LLMs hallucinate, confidently producing false information as if it were true. They are non-deterministic. Asking the same question twice may yield different answers. And they are opaque. No one, not even their creators, can fully explain why they produce one output rather than another. These traits make them poison for the back end of software development, where quality control depends on verifiable, repeatable outcomes. Software testing is not glamorous, but it is essential. Every online transaction, every hospital record, every aircraft autopilot relies on it. Testing is the mechanism by which engineers confirm that what was built behaves exactly as intended under predictable conditions. It is deterministic by design. The same input must always produce the same output. Quality assurance is not about imagination, but elimination, removing uncertainty, catching edge cases, and verifying compliance. In an era where code controls everything from pacemakers to payment rails, a single overlooked defect can cause not just inconvenience, but catastrophe. LLMs, by contrast, introduce uncertainty. They may generate a plausible test case one moment and an irrelevant one the next. They may pass code that contains subtle errors because their evaluation is based on pattern matching rather than true verification. To place them in charge of testing is not to strengthen quality control but to sabotage it. Waste with a carbon footprint. The misapplication of LLMs is not merely a technical folly, it is an environmental one. Training and running these models consumes staggering amounts of electricity. A single query to a large model can use 10 times the energy of a Google search. Training the biggest models has been compared to the lifetime emissions of dozens of cars. To spend such resources on tasks for which the models are ill-suited is doubly wasteful. Not only is the energy squandered, but the opportunity cost is enormous. These same computational resources could be directed toward domains where LLMs do create value, accelerating drug discovery, generating designs for new materials, or helping businesses test ideas in early prototype form. In other words, misusing LLMs for deterministic testing is not just a poor allocation of capital. It is a small but real contribution to environmental ruin. Why then do otherwise savvy firms fall for such misapplications? The answer lies in the sociology of innovation. Every new technology arrives wrapped in hype. Executives, anxious not to be left behind, feel pressure to demonstrate that they are doing something with AI. Middle managers, measured by their ability to innovate, seize the tools at hand and look for processes to automate. Vendors, eager to expand markets, oversell capabilities. The result is a mismatch between tool and task. Nuclear reactors were never going to power home refrigerators. Pets.com was never going to make money selling kibble online at a loss. And LLMs are never going to reliably validate mission-critical code. The pattern is perennial. Enthusiasm outruns realism. The question is whether firms can learn fast enough to avoid costly detours. Case studies in folly. Consider an e-commerce company that decides to integrate LLMs into its quality assurance pipeline. At first, the system produces a burst of efficiency. Test cases are generated in seconds and some bugs are caught. But over time, inconsistencies creep in. Tests that once passed begin to fail without cause. Edge cases slip through. Customer complaints rise. What looked like productivity gains turn into hidden liabilities. Or imagine a fintech startup under regulatory scrutiny. An LLM verifies compliance with transaction protocols, but misses subtle logic flaws. When auditors later discover the errors, the firm faces fines and reputational damage. The technology meant to inspire investor confidence instead erodes it. These scenarios are not hypothetical indulgences. They are the predictable consequences of letting non-deterministic tools into deterministic domains. The better path, prototyping and validation. Where, then, should LLMs be used? The answer is clear. In the early exploratory stages of business and technical innovation. They are accelerators of imagination, not guardians of truth. In product design, they can generate dozens of variations on a concept in seconds. In marketing, they can draft campaign slogans, freeing human teams to refine strategy. In software development, they can sketch skeleton code or simulate user scenarios, providing raw material for engineers to polish. Even in technical validation, LLMs have a role, so long as the goal is to test ideas, not to guarantee outcomes. They can suggest possible failure points or edge cases, which engineers can then evaluate with traditional deterministic tools. They can broaden the scope of early testing, but they cannot replace the rigor of final verification. A bulldog in the nursery. Every era of innovation produces its bulldog in the nursery moment, the misapplication of a powerful tool to a delicate task. The danger is not just that it fails, but that it distracts from the tool's true potential. The value of LLMs is not in replacing the hard scaffolding of verification, but in turbocharging the softer processes of ideation, simulation, and early design. Used wisely, they can make businesses nimbler, innovators bolder, and economies more productive. Used foolishly, they squander energy, time, and trust. The lesson is timeless. Technologies succeed not because they are applied everywhere, but because they are applied where they fit. LLMs are pattern machines, not truth machines. Let them roam in the yard of creativity, not in the nursery of reliability. The path forward requires intellectual honesty about the nature of our new tools. A hammer is exceptional for driving nails, but woeful for cutting wood. We must resist the temptation to use LLMs for everything simply because they are powerful.